So good afternoon. My name is Alan Hu. Actually, I come from Huawei Technology called Carrier Ethernet Group product line, and more close to R&D side. So actually today my presentation or content more reflect our R&D effort, especially for metro network. Because if you're talking about 5G, talk about cloud, telco cloud, the major impact metro network. How to go to the next directions, metro network solution, how to build the next generations. So I would say my title is called Next Generation Metro Architectures. And we want to look in some feedback from you guys. Is the right direction we want to go, right? What's the next generation metro should look like, all right? So if you check, okay, sorry about that. So actually, if you talk about metro network, if you talk about a lot of challenges, right? And we listed the key challenges here, if you agree with them. There's three key challenges right now for the metro network. First one, capacity. So if you think about it, how video-driven, a lot of application will drive capacity for the metro network. And if you have a lot of mobile network, if you give it unlimited plan, and then you drive metro network capacity, you have to build up the capacity for the futures. But the problem was, if you build the capacity with cost-efficient way, that's the key, right? I can spend a lot of money to build it, but how to get return back? This is the number one challenge for the metro network. And number two is we need a lot of real-time OEM. You need to real-time monitor your network and see what's the big challenge. You need to see what's the fault error recoveries, how to quickly monitor the errors, right? That's another challenge we have. Today we have 80% going to the manual stuff. So how to do real-time OEM? This also is a challenge for metro network. The third one we talk about is legacies. So everything you build today, will become legacies 5 years from now. So you have to dealing with legacy stuff. We have to think about when you build the next generation metro network, how to go from now to there, right? This is we have to handle this. We have to think about the migration strategy. It's really durable. Today, if you from operate side, you issue IP, take a very long cycle to upgrade. So this is I would say we have to dealing with. But if you say when we go to next generation metro network, we have some principles inside we discuss how to dealing with. First, we call legacy stuff. We have legacy metro network. If you build today network, it will become legacy in the future again. Okay? So, and then when we build today's network, we have to decouple, typically called decouple transport and service layer. This can make your life easier in the forward, because when you decouple the transport and service layers, and then you upgrade the transport layer, it does not impact your service layer. That means do not have interrupting your current services. This is number one we'll say we have to dealing with. Another way is high availability. When you upgrade your underlay metro network, we cannot touch the upper layers. That means kind of the data center today. We have data center architecture, we're running applications, but if you add on hardware capacity, does not impact your application layers. So this is also the logic behind why we need to decouple these two layers. That means when you increase the capacity, it doesn't impact your future services. This is number one, because we have to design next generation metro network, decouple service layer and transport layer. Number two is capacity growth. Capacity, if you think about a lot of idea come from data center side. If you add the data center capacities, that's right now is a little bit easy. We call horizontally expand it. So we pretty much borrow some idea from data center side that build called spine leaf architectures. And spine leaf, the way we build a spine leaf is they can easily horizontally expand your network capacities. So idea say, can we borrow some idea from data center build it up and apply to the metro network? And the third part is real-time OEM. Actually, if you check a lot of a new technology, how to leverage AI, machine learning. This is from telco space. We have to learn some new technology and apply to operation side. This is another way we have to figure out how to leverage it. All right? How to leverage new technology and improve your operation efficiency. This is also we have to think about when we design next generation metro network. And new technology also have to drive a metro network change. So if you think about, we have to reinvent metro network, re-architecture network. Why? Because typical metro network is aggregated traffic. You know, like 4G is aggregated, like a broadband, like field broadband is aggregated. But once you move to 5G era, so 5G, the key technology called CUPS, everybody know it. Actually, they have to build a lot of virtualized data centers surround it. And all 5G backhaul network eventually end up with metro network. So that means from Huawei side, our metro network, 5G is a subset of metro network. So we call cloud metro is our brand name, but 5G is part of cloud metro network. Because 5G is only for mobile side. Metro network supported for multiple services. You have to support business traffic, right? You have to support broadband traffic. So that means when we build it, we have to think about it. All this traffic have to be carried on the metro network, how to do it, how to make your network more efficient, easy to expand. Because service cloudification is really driving metro network change. We have to do it. So if you check, this is the key idea, is how to build the metro network. See, for transport layer, typically is layer 1 to layer 3, right? Layer 1 to layer 3 is transport layer. And layer 4 above is service layer. So we think about how to decouple it. It's kind of overlay and underlay in the data centers. The idea is very similar. So overlay is service and underlay is transport. Okay, so we have to make sure transport layer is more scalable. Okay, this is number one, we call metro fabric. It's kind of, when we compare metro fabric and the data center fabric, there are a lot of similarities. So data center fabric is a very successful driver OTT infrastructure, like Google data center, right? Facebook data center, they use similar idea. So we can leverage the fabric design apply for metro. This is our key direction we want to go. So we will build the product portfolio to go these directions, is number one. And for service layer, we want to more agile, flexible, means plug and play. This is typically our internal code always says we have to make sure service is plug and play. And means that doesn't avail infrastructure transport layer change. They can do plug and play. This is more agile and flexible. Okay? So if you check the horizontal, it's called Lego style to build the underlay transport layers. This is also similar like data center build it up. We will build up standardized modular box and make sure easily to horizontally scale up your metro network. You based on called spine leaf architecture, physical architectures. And if you need the new capacities, you just bring the new box and connect to there, it works. Okay? And the service layer doesn't have any impact. Your existing service is still run as it is. And you do not need to worry about the service interruptions. And can easily horizontally expand your capacity. And another part, we still going another direction is the vertical scale up. Because sometimes the box capacity is still very important. So we still need to drive box capacity called vertical scale up. We still drive, maybe today it's called 1 terabit platform, next maybe 2 terabit and 4 terabit. That means capacity-wise for each box, we have to increase it. Very similar like a CPU, right? If it's a multi-core CPU, you still need to increase frequency of CPU to address the capacity. So the logic is we have to do the two-way. And depending on scenario. Some scenarios say I just need to horizontally expand your network, and you can do spine leaf expansion. And if you need a high capacity box, we suppose to address horizontally. So two-way based on scenario, we can expand your network metro capacity. And we say the cost-efficient way to do this. And once you build up the physical spine leaf metro fabric architectures, we have to work on the protocol, typically layer 1 to layer 3. Layer 3 is the routing protocol, right? So we embrace the two simple protocol, as the industry peer does. Okay? We bring segment routing as a transport layer, and EVPN as overlay called service, enabled services. Okay? So EVPN will replace legacy with a layer 2, layer 3 VPN, and segment routing will replace MPS legacy MPS called LDP and ISVP. So this will adopt it, and you think about it, we will reduce the protocol complexity up to like 80%. Okay, and then make sure end-to-end, if you do end-to-end, more easy to call provisioning and programmability. So this is another way we will go. We will build a spine leaf architecture and running simplified protocol over it. That's the simplified metro attack. And the third one we will emphasize is called SRv6. This is also the company directions. I will say SRv6, if you are from IP side, you know it's based on IPv6, okay? Based on IPv6, and because we didn't talk too much about IPv4 to IPv6 transition at this time, right? It sounds like IPv6 is ready there. Okay, if we have IPv6 ready there, and when you migrate, okay, from v4 to v6, and we don't want to use MPLS anymore. So because IPv6, if you extend IPv6 header and add a call SRv6, this is segment routing v6 header. If you're doing that way, your network is much simpler. You only need an IPv6 protocol, no MPLS, no others. So that's, I would say, if you're doing this way, this is even more simpler in your future IP or metro network. So company-wise, we invest a lot on segment routing IPv6. We believe that's the way moving forward. And also I saw like industry peers, and also we work with operators go these directions. And this direction not mature enough at this time. And I know we work very hard with SoftBank Japan to push this in the developed in a real network called SRv6. And another SRv6, the advantage from R&D side is what? Is the programmability. Because the typical MPLS header, if you know IP, is 20 bits for segment routing ID. You don't have a lot of flexibility to program SR MPLS. But if you use SRv6, that's the 128 bit you can control with, right? So that means in the future, if you do enable IPv6 network, all the programmability you can control entire end-to-end. You really have a lot of bits you can play around. This is another advantage we say why we need to go to IPv6, okay? And if you think about IPv6, there are two kind of application-driven IPv6 network, right? One is the mobile side. You have a lot of handsets. They need a mobile IPv6 address. Another part is the microservice in the data center. If you enable a lot of virtual machines, a lot of like container, each container they need address, right? If we can enable IPv6 address in the data centers, then we can do end-to-end IPv6 segment routing from physical devices easily to reach into data centers. So this is another reasons why we want to go to these directions. Eventually, we can drive called application-driven network based on SRv6. And right now, company have a huge group work with IETF and try to draft some like IETF draft and work with other, I would say, peers and try to move these directions. Like working with Cisco, Juniper, because the IP network, we need communities. No vendors, single vendor can move, ahead. So we have to get a consensus from other vendors. Says, is it the right way to do? Okay? If it's the right way to do, we have to invest money. And we have to get support from operator side. Are you guys agree this is the right way to go? So when we present it here, and I want to listen from you guys, have different opinions. Maybe this is not the right way, then we can adjust our strategies, right? So now we put the R&D effort to go the directions. Even in the 5G backhaul, we also want to leverage SRv6 to enable mobile backhaul. So if you check this exactly from our R&D side, say before I present it, tell me, if you say you can leverage SRv6 enable 5G backhaul, how? This tell you exactly how. They tell exactly from cell site how to get into MEC, the cloud environment, and get out, how to make sure 5G backhaul works. Because 5G core network is, from my point of view, is complex compared with 4G. Because they have like a control and the unit and DU called data units separations. When you separate this stuff, all these units have to talk to each other. And a lot of elements is virtualized in the data center, right? So how to make all these 5G core elements talk to each other, some in the virtual environment, some in the physical devices, and then you make them work. So SRv6 is the ideal way to address 5G backhaul. So this is, I would say, we will put forward to this direction and make sure 5G backhaul is SRv6 enabled. All right? And one more thing is, we can do latency-based routing and latency-based path optimization with this. Traditional routings only can do the hop by hop, right? You can pick shortest path. They cannot pick lowest latency path. But with segment routing, which is called SDN controller, we have called SDN controller called NCE, why we promoted this called SDN controllers, called NCE Network Cloud Engines. And we spend a huge effort to explain to customer how NCE works. NCE actually is a combined SDN controller, legacy the network management system, and the traffic monitoring. These kind of integrated system, and plus called big data analyticals. That can, right now we have one beautiful protocol called streaming telemetry. This is very important to do big data. Because once you enable streaming called telemetry, they can collect the data from devices. And if you have data, then you know what's going on network. And you know what's going on network, you can make decisions. Right? You can say, here is the shortest latency path I have to pick. And then called NCE SDN control can push SR headers, the stack, tell me go these directions. And then you can get lowest latency path. That's how that works. So if you compare others without segment routings or without SDN control, you cannot do this easily. I say, at least cannot do it easily. Maybe you have some way to do it, but not that easy. But now we can make it easy. Okay? So that means for certain applications, and once we open API for our controllers, an application asks some specific path, is low latency based, we can make it. Right? This is all about it. Right? If you check 5G applications, so one of the key applications is latency driven. Now we can make it. Is an easy way to implement low latency parts. And another part we want to emphasize, this is kind of company strategy. We will continue to invest our chipset. If you know the Huawei side, we have our chipset company called Hisense. I forgot the name. Hisense. About 2,000 people working on this. This guy provides the chipset for our platform. So we will continue to invest that, especially for IP network. IP forwarding chipset, we'll continue to do it, and make sure it's programmable. This is another key we want to emphasize. Make sure it's programmable, which means once in the future, we don't know, maybe we have some new feature we need it, right? Because typically IP forwardings, the header is very important. You have to in-cap, have lookup headers, have to do some features. If the chip forwarding chips are not programmable, and sometimes you need to upgrade your hardware box. So we won't guarantee when we design the hardware box, we make sure forwarding chipset must be programmable. That's another strategy. We will continue to invest, both in the low-end and high-end IP box. All the forwarding chipsets programmable to address the new feature requirement, to address the new capacity requirement. Okay. And also, if you say, as I mentioned, the capacity is driven, like you have upgrade capacity, but how to reduce the cost? This is another called cost per bit is very important, right? So we will do the multiple angles. We won't say how to make the technology use conducting technology drive down the cost per bit. And I'm wrong. Okay, this pretty much is the last one. Beautiful. Okay, so final slice, I would say it's pretty much. So we have NCE. When we design, say, when we build the architecture look like, protocols, and how really deploy it, how to design this. Our philosophy, we have some tools called design studios. This pretty much is tell you how to get network planning, deployment, and verifications process. So we have some tools, and these tools combine with NCE and make sure future metro network can be easily designed and deploy and verify. So this is pretty much the whole things. Summarize a little bit. So I would say the Cloud Metro internal slogan we call is Cloud Metro is less is more, which means we build a simplified metro network to support more or sophisticated services. And the way we will do it, we'll decouple service and transport layers and simplify protocols and also make sure service more agile. And we add more intelligence on the control plane, more intelligence on the core service NCE cloud engines to do this. So this means we say less is more when we design the next generation metro network. And eventually this metro network will be for 5G, will be for all the video-driven applications. So that's the next generation architecture we're looking for. So if you want to have some comments, we can just talk to me. You agree or disagree, right? And then we can, because right now I'm saying I'm close to R&D, and we want to bring back the message from customer side. Is the right direction you want to go? Is there any challenge on it? All right?
Thank you very much.
Okay, thank you.